So oxygen has its 2, 4, 6, 8 electrons. Carbon has its 2, 4, 6, 8 electrons. And this oxygen has its 2, 4, 6, 8 electrons. So instead of one bond, having carbon with 4 hydrogens around it, it can have 2 bonds with something that also has 2 electrons that are singular. Same way, nitrogen, 2 nitrogens together, they both have 3 electrons that are lonely, and it has 3 electrons that are lonely. So they can combine, and you can have 2, 4, 6, 8 electrons here. Now this may look weird, and we're going to talk about what the bonds are actually made out of and how the orbitals overlap later on. But you can see that both nitrogens have 8 electrons that are being shared. Now, we're not going to draw 3 vertical lines. How it's represented is 3 horizontal lines with the lone pairs pointed in opposite directions. So when you think about putting electrons around, just like we did with the Lewis symbols, you can't just stick electrons anywhere. They want to be as far apart from each lone pairs as possible. So in this case, the 2 lone pairs on oxygen are opposite of each other. The lone pairs on this nitrogen is opposite of this pair of nitrogens on that nitrogen. So 2 lines means 4 electrons. 3 lines mean 6 electrons. So again, each lines represent 2 electrons. 2, 4, 6, 8, 2, 4, 6, 8. Every octet is fulfilled. So which species is most likely to have multiple bonds? Think about how many electrons each element wants around it. So you'll find that this is one of your quiz questions. So you can see, I'm not going to answer them on the slide, I'm just going to talk about them. And so you can see that carbon wants how many electrons? 4. Oxygen wants 2. So is that one more likely to have multiple bonds? Yes. H2O. One oxygen has 2 vacancies. You have 2 hydrogens with 1 electron each. That would fill each vacancy, so there's no need for double bonding. Also, it's very important to note that hydrogen will never double bond. It will not double bond. Okay? Maybe when you go do organic and some weird things, you could try to make it do it, but general chemistry, never put a double bond on a hydrogen. Okay? Same with the halogens, or at least with fluorine. Phosphorus has a valence electron of 5, so it has 3 vacancies. Those hydrogens can fulfill all 3 vacancies. Boron, same way, once you draw the Lewis structures. And there could be 3 fluorines around it. Each fluorine has 1 hole that it can share. So we have octet there. There's no need for double bonds. And we've seen methane, which is CH4 in one of our previous examples. Carbon has 4 holes. There are 4 hydrogens with electrons to fill. So the answer would be A. So the steps to drawing your own Lewis structure is you need to know how many valent electrons are total. So you need to add up all the valence electrons from all atoms, not just types of atoms, but all atoms. So if you have CO2, you have 1 carbon and 2 oxygens. You write the symbol for the atoms and connect them with a single bond. So we're going to assume that for every Lewis structure, you're thinking about covalent bonds. So if you have 2 elements, 2 atoms I should say, then you need to have a bond between them. So step 3 is complete the octets of the atoms bonded to the central atom. Okay, so what that means is there will be one atom that will be typically the first atom listed, so the cation, and or the atom that has the most bonds possible. So you will put all the players on the game. So put all the atoms that are out there written down and combined. Then you will complete the octets of the atoms bonded to the central atom. So you'll start from the outside, putting lone pairs in, and then place any electrons left over into the central atoms. If there's not enough electrons to create an octet, try multiple bonds, and we'll see a few examples like that. So our first example is silicon tetrafluoride. We will first count up our valence electrons. So silicon is in group 4. That means there are 4 valence electrons. There are 1 silicon. So 1 times 4 is 4 electrons. The fluorine is in group 7. So there are 7 valence electrons. However, this time there are 4 fluorines. That means there are 28 electrons from all fluorines. There are 32 total valence electrons that needs to be accounted for. Looking here, you can see that with silicon is first, so it's our cation. There's also, you also know from group 4 that there are 4 holes, meaning that it can be bonded 4 different times. Fluorine is in group 7. It is 1 away from the octet, so it only has 1 bond possible, meaning that silicon is our central atom. So we can draw a skeletal structure. Here silicon is in the center with 4 fluorines around it. So we have all the players on the field. We also need to make sure that things are bonded. Both of them are non-metal, so we know that they're going to be covalently bond. You see each fluorine is bonded to silicon. So there's 2, 4, 6, 8 electrons that are what we call bonding electrons. There are still 24 electrons need to be accounted for. So what we're going to do is split those up into all 4, we'll split them up between all 4 fluorines. And you start out with an electron on each fluorine. Okay. Then we're going to space it out so that way each fluorine has an electron as far away as possible from each other. Okay, so now we have 3, 6, 9, 12. We still have 24 to go. So again, now you can start bonding them. And you can see that there are going to be 6 electrons around. And I'm not going to bore you with the details. Yes, you have to do this each time to make sure that the lone pairs are where you want it to be. So you can see that we have 2, 4, 6, 2, 4, 6, so that's 12, and 12 and 12 is 24. So we can see that our complete terminal octet, everyone has octet, all arms of the fluorine, so 2, 4, 6, 8, 2, 4, 6, 8. And even silicon is complete 2, 4, 6, 8. So everyone has a happy octet. We do have lone pairs, and that is fine. Because fluorine only wants to bond once, we do not need to double bond anything. All the octets are fulfilled. To look at a more difficult case, we can see that now we have dinitrogen difluoride. So how do we identify our central atom here? Well, first, we still look at the valence electrons first. Nitrogen is in the group 5. There are 2 nitrogens, so it has 2 valence electrons, or twice as many valence electrons, so 2 times 5, 10. Fluorine, just like we saw before, they're still in the group 7, so you have 7 valence electrons. There are 2 of them, 2 times 7, 14. We have a total of 24 electrons. Now, the ones that are going to bond most would be the nitrogens versus the fluorines. However, now you have two of them. So we technically have two central atoms. And how we depict that is we put the nitrogens in the center. Okay? They will be bonded to each other, and then each nitrogen will get one one fluorine. Okay? You might see this with peroxides, you might see this with different nitrogen compounds, with different carbon compounds. So again, you still obey the same rules where the atoms that are that have more bonds will go in the center. If you have multiple of the same kind of elements, then they must all be bonded together like this. Again, you start out fulfilling the octets of our outer elements. In this case, this would be the two fluorines. So I'm going to know that they're going to be partners, so I'm going to go 2, 4, 6, and 8 around here. Okay, so 2, 4, 6, 8, 2, 4, 6, 8. There are still 18 elements left, 18 electrons left. Then you can go into the center atom. So then you would have 1, 2, 3, 4, 5. Oh, where am I? Oh, okay, sorry. We have 6 from the bond, so 2, 4, 6, and then 12 from the lone pairs. Okay, that's where we're at. And you can see, sorry, now I'm on this location. Now we have 6 electrons to go. So we have 1, 2, 3, 4, 5, 6. So we have 2, 4, 6, 7 electrons around this nitrogen and 7 electrons around this nitrogen. The octets are not complete. You also notice that there are 2 of those not even a lone pair, they're single electrons. Electrons like to be paired, not alone. So what we can do is take those 2 and share them so we can have a double bond. Okay? Okay. There we go. Again, look at how many bonds nitrogen has. 1, 2, 3. So remember that nitrogen is in the group 5. It has 3 vacancies. That means it wants 3 bonds around it. And each nitrogen has that. It has 1, 2, 3 bonds. 1, 2, 3 bonds. So pay attention to not only counting your electrons, but making sure that the locations of those bonds make sense. You would not want to double bond a fluorine. Okay, you would not put a bond between here, okay, because fluorine again only wants to bond once. So you would be having extra electrons around the fluorine, even though, and not having a complete octet around either of the fluorines, either of the fluorine or the nitrogen. So you really want to pay attention to, are the atoms happy? In this case, you have 2, 4, 6, 8 electrons around fluorine, 2, 4, 6, 8 electrons around your central atoms. Fluorine is only bonded once, and nitrogen is bonded 3 times. So everything is happy. So we'll finish off this video with a clicker question. Okay, this will be another question from your quiz. I will not go over the answer to this. Make sure you pay attention to counting your valence electrons and how many electrons are around this total atom system.